So let's do another example. So use the laws of logarithms to simplify and evaluate each expression. Now my first check might be that the logs are actually all have the same base, and they do. Perfect. And it's kind of hard to tell where I should start. Like I look here and I think, oh, I probably can't make 12 become base 2. Or I can't make 6 become base 2. Or 27 become base 2. But I do notice I've got some coefficients here, and those actually can become our exponents for what's inside of our logarithm. And so let's see what happens there. So we've got log base 2, and then this becomes 12 squared, and then minus. So this will stay the same as log base 2 of 6. And this 1/3 will become my exponent for the 27. Again, it still doesn't really look like it helps us, except for if I go 12 squared, so log base 2 is 12 squared is 144. Maybe still not that helpful, but inside of here, well, that first log stays the same. Well, 1/3 is actually cube root of 27, and cube root of 27 is 3. So that looks a little bit simpler. And maybe we'll try using a product law inside of this brackets. We're still going to follow BEDMAS with that. So this will become minus log base 2 of 6 times 3. Well, 6 times 3 is 18. And it's starting to look a little bit simpler. Now we can use the quotient law. So we're going to divide 144 by 18. Base stays the same. And we get 8. And the base is 2. And here, well, I can actually write 8 as base 2. So log 2 and then 2 cubed. And when the base are both the same, then we have our exponent as our answer, so we get 3. The next question is really similar. We should check, hey, are all the bases the same for the logs? Yep, they are. So now we can use all of our laws. Again, there's no way I can write like 6 is a base 3 or 64 is base 3. So that's not going to be my first choice. I'm going to try turning these coefficients back into exponents. So I'm going to have log base 3, 6 squared, minus log base 3, 64 to 1/2, plus log base 3 of 2. We'll simplify those exponents. So you get log 3 and 6 squared is 36, minus log base 3. Now 64 to the power of 1/2, that's like square rooting. So the square root of 64 is 8. And then we've got log base 3 of 2. Now we've got some subtraction, we've got some addition. I'm going to do this all at once. So I'm going to go log base 3. So it's going to be 36 divided by 8, because it's subtraction. And then I'm going to multiply whatever I get that by 2. Now in this case, I don't need brackets here, because this is always going to be evaluated left to right. So 36 divided by 8 times 2 is 9. So we get log base 3 of 9. And 9 can be rewritten as a base of 3. So I get log base 3 and 3 squared. So therefore our answer is going to be 2. Our next example is similar, but it has some variables in there. And now we're just trying to write it as a single logarithm because we're not able to evaluate. We don't know what x is. And we're going to take similar steps. Is all the bases the same for the logs? Yeah, they are. We have those. We have x's as part of our arguments. Now it says state any restrictions. X can actually be anything inside of there. This might be more of a concern if we're like dividing by something somewhere in this. So we're going to keep an eye out for that. So the first thing I'm going to do is use my power law, meaning I'm going to take all these coefficients and make them into the exponents inside the log. So I have log base 3, x to the power of 4. I don't want to do that yet to this one, because inside of this 1/2, or next to this 1/2, is a bracket with a couple logs. So I'm going to simplify those logs inside of there first. So we have log base 3, x, and then this coefficient becomes the exponent of our second log. So x to the power of 5. And we still have that 1/2 there. All right, next I'm going to simplify inside the brackets following BEDMAS. So we have log base 3 x to the power 4 minus our 1/2. Now, these logs are being added, so we can multiply the arguments. So x times x to the power 5, we add the exponents. So it becomes log base 3 x to the power of 6. Now, this coefficient of 1/2, I need to make it into our new exponent. So it's going to become log 3 x to the power 4 minus, well, if that goes here, it's going to be 1/2. And we're going to go 6 times 1/2, which is 3. So we get log base 3 and x to the power of 3. Finally, we have a subtraction, so then we're going to do division. Now I'm going to write this out because it's going to cause a restriction to happen. So x to the power of 4 divided by x cubed. Now we have a possible restriction here. X cubed cannot equal 0. So x cubed, well, we cube root both sides, so we find that x cannot equal 0 then. So that's going to be one of our restrictions. So now we can do this division where we subtract the exponents. So we have log base 3, and 4 minus 3 is x, where x cannot equal 0. Now our next one I really like, because it actually goes back to factoring. So we have the same base of 2 for both logs. So that's our first check always. Inside we have x squared minus 9. Another one we have x squared minus x minus 6. Problem is we can't use any log laws when we got subtraction here. However, this is a difference of squares. So I can actually rewrite this as log base 2 with x plus 3 and x minus 3. In our second logarithm, we have log 2. And if I factor this, I get x minus 3 and x plus 2. Well, now I have a multiplication, so I can actually use the log law to split these up, but I don't think that's the best thing to do. I want to make this into one logarithm, and they have the same base, so I'm going to rewrite this as a division. So log base 2, numerator is x plus 3 times x minus 3, all divided by x minus 3, x plus 2. At this point, we do have to do restrictions. So x minus 3 cannot equal 0. So that means x cannot equal 3. And we also have an x plus 2 cannot equal 0. So therefore, x cannot equal negative 2. So therefore, x cannot equal negative 2 or 3 in this case. Now we can start doing some cancellation. We have an x minus 3 factor and an x minus 3 factor. So we'll cancel those out. And so we're left with log base 2 of x plus 3 over x plus 2, where x cannot equal negative 2 and 3.